Good morning, everyone. Today's class, we are going to see about basic CMOS technology. As we know that CMOS means complementary metal oxide semiconductor. So today's class, we are going to see about how to do the fabrication process in this for preparing a CMOS device. So there are four major CMOS technologies available. The first one is N-well process. The second is P-well process. Third one, twin tub. The finally, silicon on insulator, SOI, CMOS process. So out of which, in our class, we are going to discuss about P-well process to make a CMOS device. In this process, the starting material is lightly doped N-type substrate. It has been created by adding a pentavalent impurity, example phosphorus, into a pure semiconductor. Means the single crystal is there, a silicon crystal is there, it has been doped with N-type material, so that we'll get the substrate level. The basic substrate level for this process, P-well process, is N substrate. Okay. So the wafer preparation is needed here for getting a silicon, so that the N substrate is prepared by some methodology. Example is Czochralski methodology. So what it does means, from this Czochralski methodology, we will get a silicon ingots. The ingots is going to be sliced to get a single silicon wafer. Okay. So above which the single crystal has been grown by the supportive of the pentavalent impurity phosphorus, so that we'll get the N substrate. So that is the way of preparing a wafer here. After preparing this wafer, we'll go to this second step as oxidation. So that as oxidation process will get the silicon dioxide. So SiO2 will have the major property. The three properties are dielectric property, masking property, and also insulating property. Okay. So after completing this oxidation process, we have to go to this photolithographic process. Here, the SiO2 layer acts as a barrier for impurities or dopants. So therefore, creation of opens in the silicon dioxide layer is important for the diffusion process, where the windows are created by the lithographic process, so that we can create wells for locating our PNP device and also NPN device. So as we know that the CMOS is a complementary metal oxide semiconductor, it consisting of both P transistor and N transistor, a PMOS device and NMOS device within a same single wafer. Okay. So let me go for the processing steps for preparing this CMOS by the second category as P-well processing, P-well process. Okay. So from this first diagram, we are observing that N substrate is the base. Okay. Above which we have done this oxidation process. right? So the entire portion is going to be covered by SiO2, okay? Oxidation, by the oxidation process. After doing this oxidation process, photolithography is used so that through which we can implant the P-type material. We can able to implant the P-type material, right? So the P-type material is a, as we know this, that is a trivalent impurity. Example is boron. Okay, so then we'll get this. We have created this P well within the end substrate. So the approximate measurement for this P well is about 4 to 5 micrometer. Next, we'll move to this second step process. Here the process is known as the gate deposition. So after this diffusion process done by the creation of this PL, a thin layer of silicon dioxide is grown over the substrate. See here, everywhere, right? Already it has been represented in this first diagram. So again, we are growing that SiO2 to the entire surface. So, and then it is going to be etched in some portions. And then again, we are planting this polysilicon. Means what? The doping takes place within above this silicon dioxide for creating the gate terminal. Okay. So these two are polysilicon here for meant for this gate terminal of the transistor. So this is the place where we are creating a NPN transistor. So where this is the place where we are creating a PNP transistor. Okay. So let me see the further step one by one. Now, from this third diagram shows the source and drain of NMOS. Source and drain creation of NMOS. Right? Here. Yeah. So what we are doing here, when the drain and source region of NMOS transistor are created by adding of phosphorus pentavalent impurity. So at the time, the N substrate is masked by photoresist. So what we are doing here is, the first we are planning to create a N transistor, NPN transistor. So what we have done here is, see this diagram, it shows that the creativity of this P device. So the source and drain portions of creating the transistor has been explained in this third and fourth diagrams. What it shows means, if you want to create a drain and source for this P device, right? PNP device, this portion, that NMOS transistor portion, has been entirely covered by the photoresist, right? The mask is there so that when we are implanting ion implantation takes place for creating this drain and source for this area. So this area should be protected by a photoresist. So now we are the doping level is going to be takes place within these two wells, the creations of the P diffusion. The creations of the P diffusion means what? The boron is going to be implanted in this portion and here for creating a drain and source. Likewise, the next step, this PNP portion is going to be protected by a photoresist. Then here we are going to implant the N diffusions. The phosphorus is going to be implanted here, right, to create a drain and source for the transistor. Okay. so that we can able to form a PNP here and NPN here, right? So after completing this process, we will move into this metallization process. So metallization is the process. The wire connectivity between the transistors are made by the deposition of metals like copper. So that we will get this area is going to be etched here, and then the aluminum is act as a metal like connectivity. It's going to create a communicate between the diffused area, right? So, from this drain, gate, and source, so that the metallization process has been takes place within the all the layer regions, that is drain, source, and gate region. Likewise here, all this region has been uh, connected with this metal wires by aluminum to interact with the external world. Okay, so this process is metallization. So through which we can able to feed that drain potential, right, VDD, to this one, to this transistor, as well the VSS to this NPN transistor. So for connecting these two, we'll get V out, and this is the portions where we are feeding the potential V in. So the entire circuit diagram, the entire fabrication part shows our CMOS device. So from this CMOS device, the NPN and PNP transistors are there, right? NPN and PNP transistors are there. So this NPN will be acting as a pull down transistor, and this PNP transistor is acting as a pull up transistor. So the pull up transistor and pull down transistors are connected in a series way, connected in a series connections, right? So that it has been implemented in this diagram by the V in and V out. Okay. So this is the entire processing step for preparing a CMOS by P-well process. Thank you.